In 240 BC, a man measured the size of the entire Earth. No satellites, no aircraft, no instruments beyond a stick and a shadow. And his answer? Calculated by hand in ancient Egypt, using nothing but geometry and a single observation, was within striking distance of what our best modern measurements give us today. His name was Eratosthenes, and almost nobody knows who he is. Eratosthenes was born around 276 BC in Cyrene, a Greek city on the coast of what is now Libya. He was, by any measure, one of the most intellectually restless people of the ancient world. Poet, mathematician, astronomer, geographer. His peers had a nickname for him: Beta. Not because he was second-rate, but because he was second-best at everything. He was so broad, so curious across so many fields, that he never quite topped any single one of them. Eventually, he was invited to Alexandria, home to the greatest library in the ancient world, to serve as its chief librarian. A man paid to read everything humanity had ever written down. And it was in those scrolls that he found the clue that changed everything. While reading through the library's collection, Eratosthenes came across a description of a city called Syene, about 800 kilometers south of Alexandria, near what is now Aswan. The scroll describes something strange. On one specific day every year, the summer solstice, at exactly noon, the sun shone directly into a deep well in Syene, straight down, all the way to the water at the bottom. No shadow on the sides, no shadow anywhere. The sun was perfectly, directly overhead. Eratosthenes knew that on that same day, at that same time, in Alexandria, a stick in the ground cast a shadow. A small one, but a shadow. Most people would have read that and moved on. Eratosthenes stopped. Because if the sun was directly overhead in Syene, but not in Alexandria, that meant the surface of the earth between those two cities was curved. The ground wasn't flat. It was bent. And if you knew how much it was bent, and you knew the distance between the two cities, you could calculate the size of the whole sphere. Here's the logic, and it's beautiful in how simple it is. Think of the sun as being so far away that its rays arrive at Earth essentially parallel to each other, like rain falling straight down in perfectly vertical lines across the whole planet. The sun is 150 million kilometers away. By the time its light reaches us, the rays are, for all practical purposes, parallel. If the Earth were flat, parallel rays would hit every point on the surface at the same angle. A stick in Alexandria and a stick in Syene would both cast identical shadows. Or no shadows at all. But the Earth is a sphere, so parallel rays hit different parts of its curved surface at different angles. The further you are from directly under the sun, the more tilted the surface is relative to the incoming light, and the longer the shadow your stick casts. Eratosthenes measured the angle of that shadow in Alexandria on the solstice. It was about 7.2 degrees, 1/50th of a full circle of 360 degrees, which meant Alexandria was 1/50th of the way around the Earth from Syene. He knew the distance between the two cities, roughly 800 kilometers, measured by hired walkers trained to take consistent strides. So he multiplied 800 kilometers times 50, and arrived at the circumference of the Earth. His answer was approximately 40,000 kilometers. The actual circumference of the Earth is 40,075 kilometers. Now, there is an honest caveat here. We don't know exactly what unit of distance Eratosthenes used. And depending on the conversion, his answer carries an error of somewhere between 2% and 15%. Ancient units were not standardized the way ours are. But here's what matters. The method was perfect. The logic was airtight. A man with a stick, a shadow, and a distance measured by footsteps, working in 240 BC, arrived at the right order of magnitude for the size of the entire planet. No one improved meaningfully on his approach for nearly 2,000 years. Eratosthenes lived into his 80s. In his final years, he went blind and could no longer read. For a man who had spent his life in the greatest library on earth, that was unbearable. He died in Alexandria around 194 BC. He left behind maps of the world, calculations of the distance to the sun and moon, a system for identifying prime numbers that still carries his name, and the first known scientific measurement of the Earth itself. All of it built on the same foundation: careful observation, honest reasoning, and the willingness to ask, what does a shadow actually mean? The next time you see your shadow on the ground, that angle, that length, contains information. Eratosthenes looked at a shadow and read the size of the planet in it. Most of us look at shadows and see nothing at all. If you like what we are doing here at Science for Starters, consider subscribing to our channel and check out these earlier videos. Happy learning!